We're continuing to solve linear systems by elimination, so let's take a look at the next one. We have 5x minus 14y equals 10. And we have minus 3x, computer's freaking out, minus 3x plus 8y is equal to minus 6. Now, when we encounter a system of equations such as this, where we have no matching coefficients and no coefficients that are simple multiples of others, we're going to have to manipulate both equations by multiplying both of them by a scalar. Now, we can easily do this by finding the lowest common multiple of the coefficients of one of the variables. So, when we're looking at this system of linear equations, we can't simply multiply one equation by an integer and get matching coefficients. But notice that the coefficients of x, we have 5 and we have 3. We know that they both have a common multiple of 15. They're both factors of 15. So we can actually deal with this. We can multiply the first equation by 3 to get 15x, and we can multiply the second equation by 5 to get minus 15x, which we can then eliminate in the next step. So let's go ahead and do that. Let's multiply this entire equation by 3 and this entire equation by 5, and let's see what that gives us. So we have 3 times 5x is 15x, 3 times a minus 14y is minus 42y, and 3 times 10 is 30. Okay, now since we want to use elimination in the next step, let's go ahead and write this product underneath. So we have 5 times minus 3x is minus 15x, and you can see the usefulness of this strategy. We can actually cancel this in the next step. So we have 5 times 8y, which is plus 40y, and we have 5 times minus 6 is minus 30. So we can combine these two equations. These two terms will cancel, so do these, 30 and minus 30. That'll leave us with minus 2y equals 0, or just y equals 0. We divide both sides by minus 2. That'll just give us y equals 0, which gives us our value for our variable y. So let's go ahead and plug this in to one of our equations, and let's get the value for the other variable. Let's plug it into equation 1. Let's see, we have 5x minus 14 times 0, plugging in 0 for y, equals 10. These two terms cancel. We can go ahead and divide both sides by 5 in the same step to solve for x. So we have x equals 10 over 5 is 2. So that was actually a fairly straightforward and simple example. We're multiplying both equations by a scalar. It doesn't have to be the same scalar. In fact, this scalar is 3 and this is 5. But we're trying to get them to get a common multiple that we can eliminate in the next step and solve for one variable. So now let's go ahead and write our exact solution to this system, which is 2 and 0. Now we should recognize this as the x-intercept. The x-intercept is when we have a value of y. It's also when the line, or in this case both lines, cross the x-axis. So from this we can deduce that since this is the solution to this system of equations, these two lines intersect at the x-intercept, or on the x-axis. So that's actually very helpful if we go to try and graph this thing. So very useful piece of information. Let's look at another one. Let's say we have 4x plus 7y equals 8. And we have 7x minus 3y is equal to minus 12. All right, so this is our system of linear equations, and we want to take a look at the coefficients of the variables and see if we can find a fairly simple common multiple of one of them. And I see right off the top that the variable y has a coefficient of 7 and minus 3. 7 and 3 have a common multiple of 21, which means if we multiply this equation by 3, we'd get a positive 21. We multiply this equation by 7, we'll get a negative 21, which will actually cancel our y variables in the next step. So let's go ahead and multiply this out. We have 3 times 4x is 12x. 3 times 7y is plus 21y. And 3 times 8 is 24. Let's go ahead and write this product underneath here. So we have 7x times 7 is 49. 49 minus 3y times 7 is minus 21y. And minus 12 times 7 is minus 84. All right, let's go ahead and combine these two equations. We can cancel these two terms, which will leave us with 61x is equal to 60. Let's go ahead and divide both sides by 61. Or that's actually going to give us a negative 60. Minus 84 and positive 24 is a minus 60. Let's divide both sides by 61. Those two terms will cancel, which leaves us with x equals a minus 60 over 61. So we have a value for our variable y, or excuse me, variable x. So let's go ahead and plug it back into one of the equations to get the value for y. Now let's go ahead and use the first one. We have 4 times x, which is minus 60 over 61, plus 7y is equal to 8. Now we want to solve for y, so let's go ahead and do so. 4 times a minus 60 is minus 240 over 61, plus 7y equals 8. All right, now we want to move everything to the right except for our variable, so let's go ahead and add 240 over 61 to both sides. That's 61. Now these fractions might get a little nasty in this this exercise, but it's better to go ahead and get used to it now, dealing with them, because most real-world applications don't yield very nice round numbers, so it's just the nature of the beast, so let's go ahead and get familiar with them. These two terms cancel. We're left with 7y equals 240 over 61 plus 8. We can convert 8 into another ugly fraction, so we have 61 as a common denominator. The numerator will be 488. Now we can combine those two fractions in the next step. So we have 7y equals, this will give us 728 over 61. Let's go ahead and divide both sides by 7. On this side, we'll make it 7 over 1. Those two terms will cancel, just giving us y on the left-hand side. So we have 728 over 61. We're going to flip 7 over 1 and multiply, so we have 1 over 7, which will give us 728 over 427. Okay, so it ain't pretty, but it's the answer. So let's go ahead and write our exact solution for this system of equations. We have minus 60 over 61, and we have 728 over 427. These are two exact points where these two lines intersect, or it's actually the two coordinates of the same point. This is one point, and it's a V point where these two lines intersect. And you can plug these, no matter how ugly the numbers are, we can actually plug them into both equations, and both equations will work out. So very, very interesting. Let's do one more. Let's say we have minus 10x plus 3y equals 3. And we have 25x minus 11y equals 4. So this is our system of linear equations. We want to take a look at the coefficients. Do we have two variables with coefficients that have a nice round lowest common multiple? The coefficients of x, we have minus 10 and 25, which both have a common multiple of 50. The lowest common multiples don't need to always be the smaller numbers. It just needs to be a round number, or a number that's easier to deal with. In this case, 50 is going to be pretty simple. We can multiply this equation by 5, which will give us minus 50x, and we can multiply this equation by 2, which will give us a positive 50x, which we can cancel on the next step. Okay, so let's say we got minus 50x plus 5 times 3y is 15y equals 15. All right, and the next one we have positive 50x minus 22y equals 8. Now we can go ahead and combine these two equations. These two terms will cancel, so we have minus 7y equals 23. Let's go ahead and divide both sides by minus 7. That'll cancel those two terms, leaving just y by itself. Excuse me. Y equals a minus 23 over 7, and we have a value for y. Now that we have a value for y, we can plug it into either equation to get a value for x. These numbers are smaller, so let's just go ahead and use this one. We have minus 10x, which is what we want to solve for, plus 3 times minus 23 over 7 and that equals 3. All right, let's go ahead and work this out. So we have minus 10x. Positive and negative will give us a negative. 3 times 23 is a 69 over 7 equals 3. All right, we want to move all the junk to the right, a variable on the left. So let's add 69 over 7 to both sides. This is very simple. We should be very good at this by now. These two terms cancel, so we have minus 10x equals 69 over 7 plus 3. 3 is the same as 21 over 7. We're just converting 3 into a rational number with a denominator of 7, so we can combine these two fractions in the next step. We have minus 10x equals 69 and 21 gives us 90 over 7. Let's go ahead and divide both sides by a negative 10. In this case, a negative 10 over 1, so we can deal with two fractions. These two terms cancel, so we'll have x on the left-hand side. We'll go ahead and use one more step here. So we have 90 over 7 times, we're going to flip the second and multiply, so we have minus 1 over 10. We can factor a 10 out of 10 and 90, or just cancel these two zeros. We have a positive and a negative, gives us a negative. 9 times 1 is 9. 7 times 1 is 7. And here's our value for x. Now let's go ahead and write our exact solution for our system of equations. We have minus 9 over 7. And we have y right there, minus 23 over 7. So this is the point that lies in quadrant 3 that where our two lines intersect. This is the intersecting point. It's the solution to this system of equations. I'll leave that for you to check because we're out of time. We'll do some more in the next video. So I'll see you soon.